Good evening, students. In the last class, we have explained principle involved in HCl versus sodium carbonate titrations. So already we have seen that 2 moles HCl react with 1 mole sodium carbonate in this reaction, and indicator for this titration is methyl orange. Methyl at end point color change will be yellow to pink because in the conical flask we will take sodium carbonate, in the burette we will take HCl. So methyl orange will have yellow color in sodium carbonate and it will have pink color in acid. In base it will have yellow color, in acid it will have pink color. When all the base is completed, we will get color change from yellow to pink. So this is the principle involved in HCl versus sodium carbonate titrations. Already we have seen in the last class. Today we will see the calculation part and other titrations. If you see calculation part, in the calculation part, we know that M1 V1 so M1 V1 by N1 equal to M2 V2 by N2. Let this is for HCl and this is for sodium carbonate. So here M1 is molarity of HCl, V1 is volume of HCl, N1 is number of moles of HCl. Already we have written that 2 moles HCl react with 1 mole sodium carbonate in this reaction. So N1 will be 2 and N2 will be 1. So they will give molarity of acid, or you have to calculate molarity of acid if they give molarity of base. So 0.05 or any other value. So V1 is nothing but burette reading, and here P2 is nothing but how much volume you take. Generally you take 20 ml. So if you substitute all this, you will get M1. From M1 we can calculate amount. So how to calculate amount? Amount of HCl. So based on molarity formula. So what is the formula of molarity? Molarity equal to weight by gram molecular weight into 1000 by volume in milliliters. So we got molarity from here. If you want to calculate amount, you have to substitute gram molecular weight of HCl. So what is the gram molecular weight of HCl? It is nothing but 36.5. If you substitute 36.5 here, volume, how much volume? In the experiment they will give volume can be sometimes 100 ml, or they may give 250 ml or 500 ml or 1000 ml. Depending upon the volume of sample, you have to substitute volume here. Then you will get amount of the HCl. If they ask to calculate amount of sodium carbonate, then this will be given. Molarity of acid will be given. Then this will be question mark. Accordingly, you have to substitute gram molecular weight of sodium carbonate. What is the gram molecular weight of sodium carbonate? This is nothing but a 106. So if you substitute gram molecular weight 106, depending upon the volume asked in the question, the volume will not be same for every question. Sometimes they will ask 100 ml like that, 250, 500, 1000 ml. So this is the calculation part involved in the HCl versus sodium carbonate titrations. So what is the indicator? Methyl orange. What is the color change? You have to remember. So this is about HCl versus sodium carbonate titrations. So next we will discuss oxalic acid and sodium hydroxide experiment, that is oxalic acid versus sodium hydroxide. Oxalic acid versus sodium hydroxide. What is the formula of oxalic acid? Oxalic acid is nothing but dicarboxylic acid. So oxalic acid react with sodium hydroxide. This is acid, this is base. So how many acid functional groups are there here? 2. So we require 2 moles NaOH. 1 mole oxalic acid require 2 mole sodium hydroxide. So that will give you salt COO minus Na plus. Plus you will get water. So this is the reaction involved in oxalic acid and NaOH titrations. So in this case, remember 1 mole oxalic acid react with 2 moles NaOH. And for this, the indicator suitable for this titration is phenolphthalein. Phenolphthalein indicator is suitable for this. So here we will take pipette, burette, conical flask. In the burette we will take sodium hydroxide. Here we will take oxalic acid. So oxalic acid taken in the conical flask, sodium hydroxide will be taken in the burette. So whenever we add phenolphthalein to acid, this is colorless. So the color of phenolphthalein indicator in acid is colorless. There is no color. So when we titrate oxalic acid with sodium hydroxide, after completion of oxalic acid, so it will give you pink color in base. So the end point will be from colorless to pink. So the end point will be from colorless to pink. Color will change from colorless to pink. So this is the principle involved in oxalic acid and sodium hydroxide titrations. Right. Next we will go for calculation part. So in the calculation part, what we have to substitute? Look at here. Let this is M1 V1 by N1, M2 V2 by N2. So here how many moles involving? Here 1. Here number of moles 2. So molarity of oxalic acid, they will give some value X, and volume generally we will take 20 ml. 20 ml we will take in the conical flask. Next, volume of sodium hydroxide, that is nothing but burette reading, and number of moles 2. So if you substitute all these values, you will get molarity of oxalic acid. From molarity of oxalic acid, we can calculate amount of oxalic acid. How to calculate amount? Again using same formula, molarity equal to weight by gram molecular weight into 1000 by volume in milliliters. If you want to calculate amount is nothing but molarity into gram molecular weight into volume in milliliters by 1000. So depending upon the volume, already explained, volume can be 100 ml, depending upon the question, 250 ml, 500 ml, and finally 1000 ml. So how much volume we have to take, that depends on the question. So if you take 100 ml, substitute here 100 ml, and here gram molecular weight of oxalic acid. So oxalic acid in the lab, it exists in the form of dihydrate. Oxalic acid, dihydrated form, its molecular weight will be 126. And sodium hydroxide molecular weight will be 40. So depending upon the question, whether we are estimating oxalic acid or whether we are estimating sodium hydroxide, you have to substitute their molecular weight. So oxalic acid dihydrated molecular weight is 126. The molecular weight of sodium hydroxide will be 40. So this is the calculation involved in oxalic acid versus sodium hydroxide.